Bueno, buenas noches, good morning. Les saludo cariñosamente. Les saludo cariñosamente a Karen Emory. A mi buen amigo Manuel Carreiras, a Mr. Paul que es muy amigo mío, y a todos los que estáis participando de estas jornadas. Lagun maiteok, ongi etorria aquarium mera. Queridos amigos, ante todo, quiero daros la bienvenida al Aquarium, un espacio en el que vais a encontrar un ambiente de paz y serenidad, propicio para la reflexión y el debate sosegado. Es para nosotros un honor que hayáis escogido nuestras instalaciones para celebrar vuestra reunión, que deseo sea fructífera. No os olvidéis que estáis en vuestra casa. Los seres humanos, desde el principio de la historia, han sentido la necesidad de comunicación entre ellos y les ha llevado a dotarse de un lenguaje para expresar sus pensamientos y sus sentimientos. No cabe duda de que ese lenguaje ha evolucionado, porque según convicción de etnógrafos y paleontólogos, el humano primitivo se valía de signos y sonidos rudimentarios para relacionarse con sus semejantes, mientras iba buscando mecanismos de comunicación para poder expresar lo que pensaba y lo que sentía. Evolucionadas las formas de expresión hasta lo que hoy conocemos como lenguaje oral, con todos sus matices, normas y reglas, condicionantes involuntarios, normalmente físicos, han obligado a las personas a valerse del lenguaje de los signos. Pero no se trata ni mucho menos de regresar a la prehistoria para reproducir la primitiva. Pero no se trata ni mucho menos de regresar a la prehistoria para reproducir la primitiva comunicación gestual. El lenguaje de los signos se ha ido transformando con el tiempo, como lengua humana natural que es, y se ha ido adaptando a las diferentes épocas y circunstancias. Se adquiere y se desarrolla en un contexto comunicativo determinado, y se transmite de generación en generación como la propia cultura. Los lenguajes que utilizan signos y no palabras son auténticos sistemas basados en símbolos lingüísticos con significados que se emplean para describir, clasificar y relacionar experiencias, conceptos y objetos, como sucede con cualquier otra lengua oral. El lenguaje de los signos cumple, por tanto, las mismas condiciones que las lenguas orales, aunque utiliza una vía visual, gestual, en lugar de la vía acústico-vocal. Y en eso, solo en eso, se distingue del resto de las expresiones comunicativas. Ante esa riqueza expresiva, ante la gran aportación que el lenguaje de signos ha supuesto para la comunicación entre los seres humanos a través de la historia, solo me queda animaros a que continuéis vuestra investigación sobre este particular medio de expresión. Solo profundizando en el estudio del lenguaje gestual se conoce mejor a quienes lo emplean y se contribuye a enriquecer las relaciones entre las personas. Os deseo muchos éxitos en el estudio de esa forma del lenguaje. Yo reitero mi bienvenida. Sorionak eta segi aurrera. Eskerrik asko.
Si hablo de frente. Muy bien. Toma, vaya. Arratsaldeon, ongi etorri, bienvenidos, buenas tardes a todos. Hoy tenemos con nosotros en la serie de charlas Brain Talks que organiza el BCBL junto con los diferentes eventos científicos que venimos organizando desde nuestro nacimiento, a la charla Brain Talk. Y tenemos hoy la suerte de tener entre nosotros a Karen Emory, que es profesora de la San Diego State University. Previamente realizó su carrera en la Universidad de California, en Los Ángeles, allí se graduó. Luego estuvo en el Instituto Salk, que bueno, es un instituto muy importante de California también, y bueno, posteriormente en la San Diego State University. Es una persona, una investigadora que lleva mucho tiempo trabajando sobre la lengua de signos, intentando entender en qué medida utiliza bases neurales similares a las lenguas orales y en qué medida el procesamiento de esas lenguas de signos y de las lenguas orales son semejantes. Ha realizado numerosas investigaciones y hoy pues tenemos el gusto de tenerla aquí para que comparta con nosotros todo lo que ella sabe, o una parte de lo que ella sabe, sobre esas bases biológicas tanto de la lengua de signos como de las lenguas orales. Sin más, yo creo que es momento de dejarle la palabra a ella, que es más interesante lo que ella nos vaya a decir que lo que siga diciéndole yo. Así que muchas gracias y démosle un aplauso.
So, thank you very much for inviting me to give this talk in this beautiful city, San Sebastián. San Diego is also beautiful, but the food is much better here. So what I'd like to talk about today is what sign languages can tell us about human language and the brain. And I'm going to start by just giving you a flavor of sign languages around the world. So the first one here should be familiar. It's someone talking about sign languages around the world in Spanish Sign Language. This video is actually from Sign Language of the Netherlands. It's from a corpus where they're investigating language variation across the Netherlands in sign language, and also looking at language change from older to younger signers. So she's telling a fable in Sign Language of the Netherlands. The example down here is a study looking at language acquisition. So this is a little boy telling he's deaf, telling his deaf mother about his day at school. This is from a project looking at language acquisition in Brazil and in America. And the final example here, these ones, these are actually a number of different sign languages. And these examples come from linguistics papers studying the structure of different sign languages, and these are linguistic examples from those papers. The idea here is we're beginning to really understand how different actually sign languages are from each other and understanding their structure. So what I'd like to argue today is that sign languages and the deaf and hearing people who use them have a lot to tell us about human language, why the way it is. They can tell us a lot about brain organization for language and why brain organization is the way it is, or why not. And what I'm going to do, I'd like to pose three questions. And I've selected these questions because they illustrate how sign language can be a very useful tool for understanding human language and understanding the bases in the brain for language. So one question is whether all human languages represent meaning or semantics independently from their form or the phonology. Then I want to look at what sign languages can tell us about the brain organization for language. And then finally, I want to look at something that's kind of unique to sign languages, and this is whether the neural substrate or the neural support for language and for gesture, pantomimes, are very similar, particularly when signs look very much like pantomimes. So let's start with the first question. This question arises because of the forms of sign language, of the signs, because many of them actually have some relationship to their meaning, unlike spoken words usually. So here's some examples from American Sign Language. So that's the sign language that I study most. And what I'm going to show you when I play the videos, you'll see that there's really a clear relationship between the form of the sign, what the sign looks like, and the meaning of the sign. Okay? Okay, so it's likely that you have a high degree of iconicity in sign language, partly because of the gestural origins of sign language and how they emerge. But the question is, because form is not that often independent of meaning, does this lead to really a very different, fundamental difference between spoken and sign language, where you have some of this iconicity in spoken language, but you see it much more in sign language? Does this lead to something very different in terms of how language is organized? Okay. So one question, let me go back. One question is whether or not representations of form and meaning are the same in sign language. Is there sort of a collapse between meaning and form because the form looks like the meaning, unlike in spoken language where you really have this difference between the form and the meaning? Okay? And this leads to an interesting question that you might not think about. And this is, if form and meaning are conflated, are the same in sign languages, then they shouldn't experience a parallel to what we call a tip of the tongue experience. So let me just talk about tip of the tongue for a minute, just to make sure we all understand what I'm talking about. So I'm going to see if I can elicit a tip of the tongue state in you guys. Okay, so this is, what tip of the tongue means is that you know the word you want to say, but you can't retrieve the form of the word. You can't say the word. You know it, but you can't retrieve it. So I'm going to show you a picture and also a definition, and see if you can retrieve the word. Now, if you know the word, don't say it out loud in case your neighbor is having a tip of the tongue. So we can see if you can get that feeling. Anybody have a hard time getting what that is? Okay, here's another one. Think of what that is. Anybody in a TOT? Okay. It happens even more frequently with proper names, either names of cities or countries or people. So we'll see if we can get a TOT for a person. We'll know who this is. It's an American actor. Shawshank Redemption. Morgan Freeman. Okay. Now here's what I'm told might be relevant to Spain. Do you know who this is? Because you're in a TOT. Okay. All right. So what TOT provides, tip of the tongue provides, is evidence that there's a separation between form and meaning, because you have the meaning, but you can't get the form, okay? And this has been used to find support for certain models of language production. So this is a very famous model of language production. It has lots of different stages for spoken language production. But I want to draw your attention to a division within this model. At the first part, at the beginning of speech production, there's a retrieval, what the fancy word for lemma. But what that means is you can retrieve the semantics. You can also retrieve grammatical information, so you know that the thing you're trying to produce is a noun or a verb. In Spanish, you may know whether that noun is feminine or masculine. And then, after you retrieve that information, you retrieve the form, the phonological form and the phonetic form. So there's two stages to acquisition, and to production. And what happens when you're in a TOT is you get this far, but you're blocked here. You can't get the rest of the way, all right? So for sign languages, if we don't have these two stages, the separation between semantics and form, then the question is, we wouldn't expect them to experience a tip of the finger state, the parallel state, because once you have the meaning, you have the form. Okay? So we wanted to conduct some studies to discover whether or not signers experience a tip of the fingers. And we did 2 studies. One was a diary study where we asked people to, deaf people, to keep track of whether they ever had this experience of knowing the sign that they wanted, but they weren't able to produce it. They weren't able to think of it. And then we also did an elicitation task where we tried to get people, induce people into a TOT state, a little bit like I tried to do with you earlier with the pictures and the definitions. But we used a translation task. And I'll just mention one thing here. This is actually an illustration of a signer producing in ASL. It looks like this. They're trying to think. And I suspect it may be the same in Spanish Sign Language. I don't know. Do you do this? Yeah? Do you see any nods? Yeah? A little bit? Yeah, okay. Anyway, so the diary study. What we found was that indeed, ASL signers did report this sort of feeling of knowing. That is, they knew the sign that they wanted, but they weren't able to produce it. Okay, so signers do experience a tip of the fingers experience. And in addition, they occurred at about the same rate as has been found for tip of the tongue, for TOTs in spoken language. So if iconicity, that is this relation between semantics and form, were playing a role, you might think that tip of the fingers experiences would occur much less often than TOTs, but they occurred at about the same rate. So the other thing we know from TOTs has to do with when you are able to get some partial information about the form, you often know what it begins with. So you'll often retrieve the first sound or the first letter. Okay? So our question was, all right, well, what about for sign language? Do we see partial retrieval of the form of the sign? And if so, what does that look like? What aspects of sign do they retrieve? So to do this, we couldn't really get that from the diary study because it's hard to record what part of the sign you remembered. So we used this elicitation study where we gave participants English words, proper names, or low-frequency words, and asked them for the ASL sign. And if they were experiencing this tip of the finger, so it's like, oh, I know the sign for that, we would then ask them, okay, well, do you know what the hand shape is? Do you know what the location is? Do you know what the movement is? To try to see what kind of information they could retrieve. My bet was actually on hand shape, but that, because dictionaries, for example, are organized by hand shape for sign language, or something cognitively salient about hand shape, but that's not actually what we found. What we found was that they were able to retrieve partial information, but it tended to be all together. So here's one example where the person wanted to retrieve the sign for Scotland, and that looks like this. And what the person tried to do, this is what they were trying to retrieve, they did this. Okay, so they were able to retrieve the hand shape, the movement, but what they couldn't get at first was the location. Okay, so when we measured for each of these parameters, these are a little bit like phonemes in sign language, but not exactly the same. We found that they were able to retrieve the location, orientation of the hand shape, all of these at about the same rate. What was delayed was movement. That was the hardest thing to retrieve, or the least likely to be retrieved. And it turns out that this group of features constitutes the onset for a sign. You see, when you're perceiving sign, you see this information all at about the same time. So what that suggests is, just like for speech, where you retrieve the onset of a word, you also retrieve the onset of a sign when you're in a TOT. And when we look to see whether or not whether a particular feature was iconic or not, was that more retrieved than a feature that didn't add to the iconicity of the form. We found that that didn't make a difference. You didn't retrieve sort of the iconic aspects of a sign more than the non-iconic aspects. Okay, so what this suggests is that there is a sign language phonology that fits with the linguistic results, but it also suggests that these, even when you have iconic forms, meaning and form are retrieved independently. And it also suggests that all human languages develop a level of form representation that has to be assembled during production. So for spoken languages, these components are vocal components of the lips and the tongue. For sign, they're manual components that have to be assembled. And these are from linguistic models of the forms of speech or of sign. And it also supports these psycholinguistic models that are as a universal component of having a separation between form retrieval or lemma retrieval, or retrieval of the word semantics and grammar, and the form. So you first retrieve the meaning, then you retrieve the form, either in speech or in sign. So if we come back to my question, do all human languages represent semantics independent of phonology? The answer is yes. This is a fact about all human languages. Okay. So now I want to turn to my second question, which is what determines brain organization for language? So what I want to talk about is or focus on two classic areas, and I'm going to use the classic terms for them. One is in the front of the brain, and is called Broca's area. Another is in the back of the brain, and it's called Wernicke's area. And we know from work on speech that Broca's area is important for speech production. There's other functions that go along with that region as well, but we know it's involved in speech production. And this region is involved in comprehension. Now what's interesting is that where these areas are with respect to sensory and motor regions of the brain. So if you look at where the motor face area is, it's right next to the speech production region, or Broca's area. And auditory cortex is right next to Wernicke's cortex. So this raises an interesting question about whether the brain organization, these two regions, come about because of the input-output systems for speech, because speech uses the lips and tongues for articulation, it's perceived auditorily. So we can look at sign languages to try to answer this question a little bit, because for sign languages, of course, you use the hands and arms, and the motor region that controls the hands and the arms isn't in the same place. It's more superior. It's in a different place. And sign languages are, of course, not perceived auditorily, but they're perceived visually. And the visual cortex is in the back of the brain, far from auditory cortex. So our question is, are these two regions involved in sign language production and comprehension? Okay, so let's start with looking at language output, so sign versus word production. And I'm going to tell you about a study that was a meta-study, actually, taking a number of different experiments on word production and sign production and combining them and then doing a comparison. And I want to point out that people in these experiments have been native ASL signers. What this means is that they were born into deaf families and have deaf parents and learned sign language very early. And we use this group of people in our studies because they're comparable with the hearing people who also they're born into English-speaking families and get exposed to their language very early. So we want to compare groups that get language exposure very early. And what these participants were asked to do was to simply name pictures. So this was either a sign production or a word production task. You would see pictures and produce them. And the method that we use is called positron emission tomography, or PET. And it basically measures blood flow in the brain. So when neurons are active, they need energy, and so you get blood flow towards that region of the brain. And so we can tell that that region of the brain is involved, is engaged in the task you're asking them to do. And in all of these brain studies that I'm going to be telling you about today, we will be comparing our target task with a baseline task, a task that we use to sort of subtract out or to get rid of activation that's just due to seeing something or making a decision. So in some of these tasks, it's a simple task where you have a face and it's either upright or upside down, and you decide yes, no, it's upright or upside down. So you have visual information in both, you have a decision in both, but in one you're retrieving a lexical item, you're retrieving a word or a sign, and the other one you're not, because these are unfamiliar faces. Okay, so our basic question was to look to see whether the same areas of the brain, or what are the areas of the brain that are engaged or active for both sign production and for word production. Okay? So in this analysis, what we saw was, we'll focus here on Broca's area. It was equally active for both sign production and word production. So what this tells us is that this region is not specifically tied to the speech articulators. So despite the fact that it's right in front of the region that controls the mouth and the lips, and despite the fact that there's actually connections between that area and auditory cortex, we still see that this region plays an important role in the production of sign languages that are produced with the hands. Okay? So what about the other area, the Wernicke's area? Well, we don't have a large meta-study that compares lots of studies, but this is some examples of studies that have looked at sign language comprehension in a number of different sign languages, British Sign Language and Quebec Sign Language and American Sign Language. And remember, you're perceiving a visual language, you're watching a signer, and yet we still see activation in this region that's near auditory cortex. So what that suggests, again, is that Wernicke's area is not a speech comprehension area, and it's not tied to auditory speech processing. It's involved in language comprehension, regardless of whether that language is spoken or signed. And I'll mention one other finding that's relevant to comprehension and processing, and that is that, well, actually, let me go this way. Looking at, now we're looking at the structure of the brain, so not the function. We compare the gray matter, that is where the cells are and the supporting cells are, in auditory cortex for congenitally deaf individuals and hearing individuals. And one region, Heschl's gyrus, that's the area of the brain that's often called primary auditory cortex. It's where the first region in the cortex that receives sound signals. And when we compare the size of Heschl's gyrus in deaf and hearing people, there's no difference. So gray matter the cells don't atrophy and die in auditory cortex. And the same is true if we look a little further along in superior temporal cortex, which is overlaps with Wernicke's area. We again find no difference in gray matter between deaf and hearing individuals. So one possibility, this cortex is still active in part because it's processing visual information, including sign language. Okay? So auditory regions don't disappear for deaf individuals. They become used for other processes. Okay, so if we come back to my sort of title question, is brain organization for language determined by the input-output systems? What sign languages tell us is no. These two kind of classic areas for comprehension and production are also involved and play critical roles in sign language production and comprehension. So the brain seems to be organized for language, not for speech. So if we come back to my question, what determines it? Well, not the anatomy of the motor and sensory systems. But I don't want you to leave here thinking, I would be very remiss if you left here thinking that those are the only two areas that are involved in language processing. Language processing is very complex, is a complex system. This is a recent model that's just for speech perception, okay? And we're now just beginning to sort of tease apart whether aspects of this complex system, all of the different aspects apply to sign, are they speech specific or not, okay? So we're just at the beginnings of trying to understand whether these kinds of complex models apply to sign languages as well. Okay. So let me come to my last question, which is whether the neural substrates, that is the neural support for language and gesture production, are they different? And we get this question because, unlike words, signs can actually resemble the gestured action. So this is, again, this distinctive aspect of iconicity that you find in sign languages that you don't see in spoken languages much. So in spoken language, the word scrub has nothing to do with the action of scrubbing, or the verb drink doesn't. But as I'll show you, these verbs in American Sign Language, and probably in language, Spanish Sign Language as well, look very much like the actions that they denote. So these particular verb types that exhibit what I call sort of sensory motor iconicity, or this pantomimic type iconicity, are called handling verbs in ASL. So I want to tell you about two studies that investigated the neural representation for these types of verbs. The first study, where we compared these handling or pantomimic verbs versus verbs that didn't exhibit this type of iconicity. And the second one was a direct comparison between verb production and pantomime production. So the first study, again, we used positron emission tomography. One reason we use this technique is it is sensitive, or less sensitive to movement. So you can actually move quite a bit in the scanner. And so we're asking signers to move a lot and to produce signs or pantomimes, or in this case, signs. And what signers in this experiment were asked to do was, it's again a picture naming task where we showed them pictures and we asked them to produce the signs for those pictures. But before I tell you about what we found for the sign production, I need to tell you something about what regions we know are involved in pantomime production from hearing individuals. So when hearing people are asked to pantomime, what areas of the brain are involved? And one region that seems to be involved, in addition to others, is the superior parietal cortex. This is at the very top of the brain in the left hemisphere. Okay, so this comes from experiments where you ask people to produce different kinds of tool use pantomimes. Okay, how do you use a tool, for example? Okay. So our hypotheses, given what I've told you already about word production and sign production and pantomime production, you can think about if these pantomimic type signs pattern like pantomime. Okay, if they're more like pantomime because you're using those kinds of motor information, then they should look like pantomimes in the brain. We should see greater activation for those types of signs in the superior parietal lobule in SPL. Now, if pantomime signs pattern more like spoken words, then we should see activation in this Broca's area. So when hearing people were asked to pantomime, they don't show activation in Broca's area. And similarly, well, actually, let me leave it there. So, so that's the basic idea. Do these verbs pattern like pantomimes, or do they pattern like verbs that we see in spoken languages? So signers were shown pictures like this, and they were asked to produce the sign for the picture. Okay, and here's some examples of what the signs look like for each picture. So we compared the production of these types of verbs with actions that didn't involve any kind of handling, any kind of tool or implement. Okay? So here were pictures that elicited those types of verbs. Oops, there we go. Okay. So the idea here is if the pantomimic type verbs, like the hammer example, if those, or the race example, if those verbs are really verbs in the sense that you're retrieving a phonological form, you're retrieving a hand shape and a location and a movement, and you're assembling them together, then they should look very much like these verbs, okay? So if the hand shape in the handling classifier verbs is really part of the phonological form, then both verb types should look similar. You're retrieving hand shapes, locations, and movements for both verb types. On the other hand, if you're doing something different with these handling verbs, then these two verb types should look different. Okay. So what did we find? No difference. We found that both the pantomimic type verbs and the non-pantomimic verbs, so the handling verbs and the non-handling verbs, looked identical. They both engaged Broca's area. Okay. So this is very similar to the type of activation that we see when we ask English speakers, for example, to do the same task, to produce English verbs for those pictures. But what about when we directly compare the two? When we directly compare the two, we don't see any differences in activation. So you might think for the handling verbs, if they're really engaging pantomimic type regions, we should see more activation up here in this superior parietal region, but we don't see that. So what this suggests is that the brain is treating these verbs as verbs. The brain's not treating them as pantomimes. You see activation related to language, not to pantomime. So what about our next study, where we actually do a direct comparison between producing a pantomime and producing a sign? So one thing to think about is what processes are involved in pantomiming versus signing. So when you think about pantomiming, the shape of the object, or the use of the object, is determining what the pantomime looks like. So if you're going to pantomime drinking from a shot glass, or drinking from a straw or a cup, those pantomimes are all going to look very different. It depends on the shape of the object. The object is determining what your pantomime looks like. However, for signs, this form is stored in your lexicon. It's stored in your brain as the sign, meaning to consume a liquid, to drink. So this sign, drink, can be used even if you're talking about drinking out of a shot glass or out of a cup or out of a straw. Okay? So what's determining the form of that verb is your lexicon, is your language. Okay. So to investigate the difference between these two types of production, we had participants do 3 tasks, and I'll go through each of those. We had the deaf individuals, the signers, do a classic verb generation task. So this is a task where you see an object and you have to produce a verb that's related to that object. Then we had both our hearing participants and our deaf participants do the same kind of task, but now you're asked to produce a pantomime that goes with that object. And then we had a baseline task. Again, we're doing this contrastive comparison where you see an object that's manipulable and you make a manipulability judgment about that. So let me show you what these look like. So for the verb generation task, we actually had 2 sets of pictures. So one set elicited these handling verbs, these sort of pantomimic type verbs, and the other set elicited non-pantomimic verbs. Okay, so again, we could do this contrast between verbs that look pantomimic and verbs that don't. So I'll show you what those look like. Okay, so here are two examples of the objects that were presented and the signs that would be produced. Okay. And here's examples of objects that elicited non-handling verbs. Sorry. Okay. The last one's my favorite, pour syrup, or pour salad dressing, you can use pour. Okay, so you can see these don't look like how you would handle the object. Okay. So we also asked participants to produce the pantomime that goes with objects. And for the hearing non-signers, we also asked them to produce pantomimes to those objects where the signers were producing verbs. So the example of the pen for write and the hammer for to hammer. So the pantomimes that the hearing people were producing looked very much like the ASL signs, but they were pantomimes for the hearing people. And then we had another set of objects that both deaf and hearing people produced pantomimes for. And here's some examples of those. Okay. And we also tested to make sure that the ASL verbs that were associated with these pictures looked different than pantomimes. So for example, the signers couldn't kind of cheat and produce verbs instead of pantomimes. So I'll show you the ASL sign for sweep, which is what goes with broom, and eat, which is the verb that is elicited when you, for fork. Okay, so those were sweep and eat. Okay. And then the last thing is our comparison task, where you saw, again, pictures of mostly manipulable objects, things you can hold and manipulate, and then every once in a while a non-holdable object, and you just indicated with a thumbs up that you could hold it or a hand wave that you couldn't. Okay? And the idea here was we can, again, get rid of activation that's just has to do with looking at and thinking about manipulable things, and making a decision, so that we're really focusing on the neural regions that are engaged in verb production or pantomime production. Okay. So here's what we find for our deaf group. As we would expect, we see superior parietal activation at the top of the brain. It's pretty extensive for the deaf individuals, and it's also bilateral. You see less, but you still see some activation in the right hemisphere. When we look at our hearing group, we also see superior parietal activation, but it's much less, and it's not bilateral. We think what's going on here is our deaf individuals are very good pantomimers. They have very rich pantomimes, and they're not only rich, but they move a bit more and involve two hands often. So for example, if you saw a spoon and you had to pantomime stirring or using the spoon, a hearing person might just do kind of a lame little something like this. A deaf person might actually show a bowl or a cup or something and show both aspects of the scene, often also repeat them. So our deaf signers were producing more complex pantomimes, and also, they were similar, so they weren't completely different, but they tended to be a bit more complex and also much crisper hand shapes. Okay. But our key question was really looking at pantomimes versus verbs. So when we look at the deaf individuals, now they're not producing pantomimes, they're producing verbs, so they're asked to produce a handling verb. And what we see is activation in Broca's area. Okay. And when we ask hearing people to produce a pantomime for the same objects, there's no activation in this region, but again, we see activation in parietal cortex. It's indistinguishable from the other activation for the other pantomime group. Okay. So now what about the direct comparison between the pantomimic type verbs and the non-pantomimic type verbs, the ones that don't have this handling kind of iconicity? This is a little bit different image. It's the color palette for pet. And if there was a difference, you would see dark red for handling verbs or dark purple for the other handling verbs. But it's all green, meaning that there's no difference between the two. We don't see increased activation, for example, in parietal cortex for the handling verbs. The brain, again, just like in our previous study, is treating these two verb types very similarly. So if we come back to my question, are the neural substrates for language and gesture production distinct? I would say we do see differences in regions that are engaged for these two types of manual production. So for signs, when you're producing a sign, you engage language regions, in particular Broca's area, or called left inferior frontal cortex. For pantomimes, we see much more engagement of the superior parietal region. We know that that's involved in all kinds of motor planning, object manipulation, reaching, those kinds of processing. Okay? Okay. So what are my take-home messages from this talk? What I want you to leave here and to understand. One is that despite the fact that signs exhibit this kind of iconicity, this relation between form and meaning, it does not fundamentally alter the basic structure of human language. So we see the same kind of two-stage access for sign languages as for spoken languages. It doesn't seem to fundamentally alter the neural systems that are engaged in language processing. So we see that these sort of pantomimic and non-pantomimic signs are treated the same. Now, it's not the case that iconicity doesn't matter at all. It's very important for things like sign poetry and metaphor and sign play. It's one of the things that makes signs so wonderful to watch when you're looking at a poem or at people playing with sign. People are aware of these iconic features and draw on them. But in some ways, it's the most skilled signers who are able to draw on that iconicity the best, the poets. Okay. The other take-home message is that the brain is really organized for language, not for speech. What the brain cares about is language. And so we see left hemisphere being involved in sign production, just like the left hemisphere, or in sign processing in general. Just like the language hemisphere, the left hemisphere for spoken language is the hemisphere that's involved in both sign and speech comprehension and processing. The two classic areas that are involved in language comprehension and production are also involved for sign. Okay. So I want to end by saying, one, thank you guys all for your attention, for coming. I also want to thank all of the deaf people who participated in our experiments. Without their volunteer efforts and their time, our research simply would not be possible without their help. And I also want to mention that it's important to have deaf people involved in this kind of research because they have many more insights into the language than a lot of the hearing researchers do. And so I'll just point out for our team, we have a number of deaf and hearing, or deaf researchers, and Steve McCullough is the deaf researcher who's been involved most in our neuroscience projects. And he has his PhD in cognitive neuroscience from UCSD and has worked with us for quite a while. And of course I have to thank funding. All right. So I'll stop there, and I'm happy to take your questions.
So I'll ask a question.
Okay.
So you mentioned that beyond the simple. So thanks for the talk, Karen. You mentioned that beyond the simple two-area model of Broca and Wernicke, there are lots of other areas that are involved in language processing, and we're looking at more complicated distributed networks rather than simple areas. And you talked about the fact that these other areas, so it seems clear that both Broca and Wernicke are core to spoken languages and sign languages. But for these other areas, there might be some that are specific to spoken language and some that are specific to sign language. So one of the big questions in research into sign language was the role of the right hemisphere. And there might be areas there that are specific to sign language. So could you talk a little bit about some of the areas or functions that might be more specific to sign language, and maybe the consequences of being a sign language user for those areas?
Sure. So, okay, sure, yeah, so that's great. So with respect to the right hemisphere, there is a function of the right hemisphere that seems to be unique to sign languages that you don't see in spoken languages, and that has to do with spatial language. So when you're talking about where things are in space, how they're situated, or how they move through space, the way you do that in spoken languages is usually through prepositions or special spatial morphemes. So there's a morpheme that says, okay, it's in a vertical central relationship, so above, for example. But in sign languages, that's not the way that sign languages, any sign language to my knowledge, uses a sort of closed class, a particular lexical item to mean above or on or under. In general, in everyday conversation, you use signing space itself. So if I want to indicate a clock above a table, I can do this. If I want to show it far above, I can do this, I can do this, I can move it in lots of different places to indicate exactly where that clock is with respect to the table. It seems that that kind of production engages the right hemisphere. So when you're talking about space, you engage right parietal regions to a much, much greater extent and to a special extent for sign language compared to spoken language. And I'll mention one other finding that's a similarity in a region that's not in these classic regions. So one region that people have been studying a lot recently with respect to semantic processing is the anterior temporal lobe. So these are sort of very far in the front. It's in the same lobe as Wernicke's area, but you're very far in the front. And those areas seem to be important for semantic processing, in particular for when you need to be specific. And when you compare lexical signs to these what are called classifier hand shapes, so in these spatial arrangements where I do clock above the table, okay, this is a hand shape that doesn't mean table itself, it means flat surface. This is a hand shape that means circular flat, okay? When you compare the production of those hand shapes with lexical signs, you see that lexical signs activate these anterior temporal lobes to a much greater extent because you have to be much more specific. It's a table, it's not a desk. It's a hammer, it's not a chisel, okay? But with classifier hand shapes, you don't have to be that specific. They don't engage that region. So for semantic processing, we see, at least from this one study, similar regions of the brain active. But when you look at spatial language, you see differences. a long answer.
¿Más preguntas? No more questions? Okay, so let's thank Karen. Me dice... Sí, aquí. Me dicen que les comente que las charlas están colgadas en nuestro canal de YouTube para que se lo comenten a sus amigos que al ser domingo no han podido acercarse y estén interesados en las charlas. ¿De acuerdo? Venga, gracias, hasta luego.